Grading boosting algorithm. It is very useful algorithm mainly in the ML competition because it mostly time give better accuracy or the highest accuracy as compared to other algorithm. So without any further delay, we move to the implementation part. So, so So first we import, as usual, we import all the main libraries. For I import pandas for the data to show the data set. Scale and pre-processing import min-max scaler for pre-processing. I use min-max scaler. You also try with standard scaler. There are many type of, so you can try standard scaler or min-max scaler. Then after, for splitting the dataset, I import train test split, and to show the report I just classification report and confusion matrix, and the last is algorithm itself. So next, then I import the dataset train or test. There is two file, one is name for train and other is for test. You can find this file in the description below, as well as the whole code GitHub notebook in the description. I usually try this algorithm in the Jupyter notebook. You can also try in Google Colab, both are. Then after that I drop that column survive, because I want to merge train or test, and due to this I just remove survive, because survive is our dependent column, means for which we need to predict the value. So initially I just remove this. After that I add, then full data train data dot append test data. Append means to add, means just combining train data as well as test data. These both data I combine. Then after that I drop the column. We can drop these column by seeing the data set. If there is no requirement of some column, so we just need to remove to gain better accuracy or a better result. For example, name there is no use of name in the prediction of that this person is survive. For example, by not seeing that person name is Ram, so he is survive or not, so it is not important column, so I just remove drop column. You can drop according to your seeing your data set. Then train data dot head, just print the top 5 value of train data set. So there is a, then shape is means total 891 columns and 11 rows in our data set. Then we full data equals to pd get dummies sex full data, means for example sex there is male female female male, so for encoding them we use these dummies, means to print male equals to 0 and female equals to 1 for data pre-processing. So just I convert male equals to 0 and female equals to 1. Then after that full data dot head is one that we combine from test or train. So full data dot value 0 colon 891 this show this as train, this is training dataset, or this is test dataset, that we get 891 value in the train dataset. That's why we put 891 here. So 0 is include but 891 is not include. This thing you need to remember. Then we need to do feature scaling. For feature scaling, scaler dot min max scaler that we already import above. Then fit transform. These all are feature scaling. After feature scaling, we just state equals to 12, test size equals to 0.30, means 70% of data are kept as a train and 30% is used for validation. Not, we cannot say the test size, which we put this data for the validation, because test dataset is already given here. So we need to put 70% for the train, 30% for the validation. Validation is just like that, we train the 70% of dataset, then validate is just like the test the dataset on the same algorithm that we apply on the train dataset. So after we get good accuracy on validation dataset, we can move on the test dataset, applying this algorithm on test dataset. So I just validate this data. After that, LR list means learning rate. I just put 0 0.05, 0 0.075, 0 0.1, all the possible value that I think, so I just put there. You can also put other value if you think that this also show the better result, just put here. Then I just run the loop and I apply gradient boosting classifier and an estimator, same just like. After that, I just run this cell and I get when learning rate is 0 0.05, accuracy is 80% on the training set and the validation set 73%. 0 0.075 means this one. So I just see that when the learning rate is 0.75, so it gives the maximum accuracy, that is 87%, and the validation set is 0.75%. that is good as compared to other. So next I finalize this value and put the best accuracy from here and print confusion matrix and classification report. So confusion matrix showed that out of all the value, 144 142 plus 65, this one and this one are correct according to your dataset, and 42 plus 19 are predict wrong. And these are classification report that जीरो वैल्यू के लिए 0.77 precision, 1 के लिए these are the and the accuracy is that we got from here the maximum, means just print this line, you get the accuracy also. So this is all end of the gradient boosting algorithm. There are other type of boosting algorithms such as cat boosting, SG boosting, or lib boost. There are also this also provide very good result on applying that. This I will show in the next video. Thank you for watching. Thank you.